Well, hi, and welcome to my shop as I get going again on this Hallicrafters multiband radio, kind of styled after the transoceanic sort of style. Now the cabinet is not in here. I've been working on the cabinet, not so much on the cabinet, which is in great shape, but some rust and corrosion, very serious corrosion problems that were really making this radio look ugly. But in fact, it's not ugly, and I've had an easy time correcting all the rust. For instance, there's a horrible shot of rust on here, but you can't see it anymore. I painted over it. It's just right along here. Just this strip here. Terrible looking. But look, just a little bit of black paint. You don't even know anything happened. And the rest of it is coming out this way too. So I'm very excited about the condition of this radio, the look of it. And you're probably wondering, what happened to the pointer? I had to get the pointer out of the way. Well, you probably weren't wondering. I started wondering. So, this is as I mentioned, this is a transoceanic style of radio. One manufacturer came out with a portable, big, leather case type suitcase sort of radio, and the other manufacturers followed quickly afterwards with their version of the same sort of thing. So this is the Hallicrafters transoceanic styled radio. This one's called I think it's called a TW2000, maybe a 2000 worldwide is what this one's called. As I mentioned, made by Hallicrafters. Now, unlike most of the radios I work on, this is a communications grade receiver, not professional grade, but still a communications grade receiver. So the potential for this radio to be an excellent receiver is higher than most of the radios I work on. So one example of that is, look at the capacitor has 3 sections. In most of the radios I work on, there's just 2 sections, of course. There's 3 in this radio, so that's already a hint that it's one step ahead. Now this radio is designed to work from batteries or to be plugged in. Here's the plug-in. The batteries would be, large, high voltage, 45 volt batteries and stuff like that. Inside the cabinet, the batteries can sit up in this area, in this volume, empty volume up here, because they are large. So you can picture yourself carrying this radio, battery operated, down to the beach to enjoy a nice summer's day while you listen to Radio Moscow or something like that. Doesn't have many tubes, and the tubes are very special. It has 1, 2, 3, 4 tubes. Rectification is done with a diode, not a silicon, a germanium, an old style rectifier. Let's put it that way, which I'll probably replace. It has this very heavy-duty antenna in it. This very large, very heavy piece of I can't think of the name of this material, the black material here. And of course, the building of this antenna and the way these coils are done is a critical part in making the radio work well. This is probably only AM band, and the antenna connections are here. There's a large whip on this radio, and it plugs into this terminal here. It's a very long whip. Going back to the tubes for a minute. Oh, there's another tube back here. So there's 5 tubes. Five tubes in here. They are the 1 volt style tube, actually 1.4 volts on the heater. Typically the numbers on here start with a 1 to indicate they're the 1.4 volt tubes. And my experience with this style of radio and these tubes, these low voltage tubes, is horrible. At one point I burned out a whole radio's worth of tubes just by making a stupid but simple mistake. So I'm very wary working on these guys. It's a real multi-band radio. It has many bands. 7 bands. The bands are not continuous. Oddly enough, I studied this last night and I was surprised to see the shortwave bands skip over bits and pieces, and I really don't know why. So for instance, this band goes from 3.9 megahertz up to 8. So you'd think there'd be a band here that starts at 8, but the next band starts at 9.22. So this is probably 9 out here. 22, 24. So there's sections that are missed. The other thing that's odd then is if this is a band spread radio and they put the broadcast bands on here, then you'd look over in here, you'd see something like 31 meter band. Oh, excellent. So this is the 31 meter band. But when you look at the actual band range, it's way beyond the 31 meter band. It starts at 9.2. That's about the bottom of the 31 meter band, but it goes all the way up to 10.3. In my mind, the 31 meter band is about here. Now, something really interesting happens in this radio, usually considered a real detriment, but this radio on this side of the dial is spread. The band is spread, but on this side it's compressed. It's an extremely non-linear dial. So if we look at, say, this band here, 3.9, okay, here's 4.9. So that's 1 megahertz that wide. Now if we look over here, 1 megahertz is only this wide. So the band crunches. So in effect, and over here is the actual broadcast area. So in effect, they've got the broadcast area spread and then extra on top crunched. Was this all by choice, or I don't know? It doesn't make an awful lot of sense to me what they've done here, because it looks like an attempt to cover the entire frequency spectrum, shortwave spectrum, but no. 1.8, 3.9, 3.98. This is going to be like 9.15 or something. 10.3, 11.4. Skip 12, 14. It's almost as if they purposefully stretched the band up to a number and then chose to skip beyond it. I don't know what they're doing. The other thing that's kind of crazy about this radio, the part that I like on these dials, are all these cities that are written on here that you can tune in. Like here's a city, China. That's a little vague. Here's another city, Japan. Cairo, USSR. So all these words in here, where most of them are written, apply to this band. But it shows them going all the way out to the top here. 10.2. Here's Java. Here's Nicaragua, supposedly at 7.5, outside of the band. Iceland. And there'll be some places on here that don't exist anymore, I am sure, if we look long enough. So I kind of get a kick out of that. That's kind of neat. Great looking dial. So on this side, they have sort of a description of what that band should do. So the top band is a weather, marine, and amateur band. These days, it's pretty much a nothing up here, below 4 megahertz. Next band, all day. All day, these are the two high frequency, 15 and 17 megahertz. Afternoon and evening, that's a 31 megahertz band. Navigation in this brownish colored band here. This goes from 18 to, no, goes from 180 kilocycles to 380 kilocycles. So this is a long wave band. Here, they've changed the color of it. I don't know why they show a different color. Plus, there's a very peculiar symbol right in the middle here of this band. I'm not sure what that means. If that's just marking the very center, and maybe that's for some alignment purposes, and they made it look kind of fancy in here. I don't know what that is. Or is that marking a special station? This could be marking the location of a special station. These marks here, this is the AM broadcast band down at the bottom here. This mark, and you can see another one here, are civil defense marks. And this is where the Americans had planned to broadcast during some civil defense crisis that might be happening. So you tune your radio either here or here, and then you'd get the you-know-what scared out of you by what you heard there. This location is roughly 640, and there's a strong local AM station here. So that kind of tells you the vintage of the radio too, and the fact that this was produced during the fear of nuclear attack. A fear I never seriously felt in my life, anyway, even though I live right next to the target. Great. So what's my aim here? So I believe when I worked on this radio last, my objective was to prove that it operated, and that took quite a bit of time to get through a little bit of monkey business with it, but finally get it operating. Although I don't think I tried receiving anything with it, I can't remember now. All I know is I was really happy it works. And now I think my job is to make it work well. I think that's what I'm doing now. I also believe, sort of remember, that I powered this thing from my shop power supplies. I never plugged this directly in. Or did I? I don't remember. And yes, I could look at my videos and find out, but that wouldn't be as much fun as just starting over. I think we're going to tip this up. Let's tip it up this way. It's all original under here except for this part, which I replaced. I'm going to vaguely remember that there was an open resistor here. And this was part of the challenge in getting this guy going. It still has all its original capacitors. There's a wax one here, but there's a older Bumblebee style here. And then there's all these reddish colored capacitors. My experience with these reddish ones has been poor. These look good, and I'm not going to rush in and change them until we get the set receiving a few things and make some rational decisions. Got a large electrolytic here, and must have filter up on top here somewhere. Oh, this great big one here. So it's wrapped in cardboard. It's mounted on an insulated plate. So since I'm not seeing the capacitor shell bolted directly to the chassis, that starts sending a few messages about this radio. And is there a power transformer in it? There's not. There may not be. Battery operated radio doesn't need a transformer. It's going to have to operate at voltages supplied by a battery. So B plus in here is going to be around 90 volts, something like that. You can get 90 volts without using a transformer because it's less than 120. I mean, you can get 90. So this radio very simply takes the 120 coming in, rectifies it using this rectifier here, and it's just a really simple one big fat capacitor trying to calm it down. This guy's, how many sections is this one? It's like 80, 40, 40, 80, 40, 40. So the 80, I didn't notice the two 40s here yet, but the 80 is the first thing in the filter. And then after that, with a dropping resistor, it developed 9 volts to apply across the 5 tubes that are in here. 9 volts, so we take 5 times 1.4, that's roughly 7.5, that's roughly 9. Something like that is happening anyway. So the idea though is kind of in my mind, you plug this guy in and there's just a diode and a capacitor and a resistor controlling the current flow to the tubes. And I've already mentioned I'm just really nervous about working on a radio like this. Last time I powered it up the tubes directly from a power supply. I could control the voltage very carefully going to them. I vaguely think I did plug this in. So how am I going to proceed with this? This guy draws only 20 watts when it's operating. This is the whole idea is that this is a battery operated radio, so they don't waste any power anywhere. Yeah, battery operated tube radio. These tubes are developing 1.5 watts or I don't know, maybe 2 watts at the most, these little guys. Make one mistake and the tubes are shot. Incidentally, with these radios, this is one of the lessons I learned the hard way. If it's operating without one tube in, or if you pull a tube out while it's operating, you say goodbye to the rest of them. There's a big warning on here. So the warning is not on the chassis, it's back on the cabinet. So unfortunately, once the chassis is out, the warning is no longer with the chassis. But I'm given the warning, and I paid the price. The tuning here is by a tumbler. The band change, rather. Now, you don't normally have to reach your hand in. I just can't turn that thing from the front here with the knob off. So this is very reminiscent of older TV sets when we had 12 or 13 channels. Rows of contacts. Pretty dirty. Don't put your fingers on them. Each one of these little sections here, let me turn it back, has components underneath it. You can see some of them in here. You can actually pop these sections out, put their components, work on them, pop them back in. There's a few capacitors in here that might require some attention. So as you change bands, you are switching instead of switching a selector switch and selecting different coils, you're actually rotating the coils into the circuit, snapping them in. Probably one side is RF and the other side is probably the oscillator. And I think if we turn this a little further, whoa, come on. I just hit the end of the road here. That's the end of the road. We have some trimmers here. And that looks like all of them. So you'd have to guess you must put this into a particular band to expose these and then do an adjustment, something like that. Goes on. Maybe they're done from above somehow. Lots of components tucked up inside here under these RF front end tubes. This is the battery plug for battery if we were going to use that. And unfortunately, I'm not going to show it now, way up in behind the tumbler wheel are two Bumblebee capacitors. I could see, and there might be more up in there. Though these Bumblebee style are highly unreliable. That's been my experience, and I think that's the word on the street. Now I mentioned this is only 20 watts, and I was heading somewhere with that. I have a dim bulb system here for controlling power going to the projects I'm working on. And the dim bulb system works really well for typical radios that are not too big and not too small. If they draw too little current, this big radio is actually small in that respect, only 20 watts, even though I might have a light bulb in series with it, it's going to get all the voltage out of the line. There's going to be almost no drop on the bulb. There's no restriction, and there's still protection. If there's a short in here, like a really bad short, the light will still protect things, but it's not going to reduce the supply voltage. And this is an issue to me right now because I'm concerned when I start this guy up, these tubes are going to get too much voltage on the heater for some reason. I don't know why that would happen, but I'm just so concerned about it. I would like to raise the voltage up slowly. Now a lot of guys, shops will have a variable supply they can do that with. I don't have a variable AC supply. I just got a couple of stupid light bulbs. So how am I going to start this thing with caution? That's what's going through my head. How am I going to start it cautiously? I would want to read the voltage at the start of the tube heater string and make sure it's 9 or very close to 9 where it's supposed to be. Bring the voltage up and then see the 9 coming and make sure the 9 isn't 25 or something like that. Could pull all the tubes out and turn it on, but I'm not going to get the correct reading because there's voltage drops involved in creating the 9. The 9. Using some other kind of resistance, using a step down, using a step up transformer backwards. You know what? That's a possibility. That last one's a possibility here. Let me just crawl around on my floor for a second. So, in here, in this very nice box, is a transformer that you plug in the wall, and out of here comes 240 volts. Of course, that's the opposite of what I'm after. I'm after, let's say, half. If I can run 120 volts into here, I will get something like 60 out of here. Sounds like something worth trying. Let me work on this just for a bit. See what happens. Okay, I'm all set now to get 60 volts out of here, and I'm just going to use clip leads to go up to the radio, maybe. But I want to check the voltage on this before I hook it up and turn it on. I want to be sure, A, it is really about 60 volts, and then most importantly, I need to be monitoring the voltage that's reaching the tubes to see that it's going to be something like half the intended voltage, the intended voltage being 9, so half would be 4 or 5. So my plan is to just do this. It's only a 20 watt receiver, almost no power going through here, no current. But before I do that, I really want to read the voltage. Let's use the digital meter. It'll be fine for this. So we're hoping for about 60 volts here. My thinking is with 60 volts, if there's something wrong in the radio and it's about to apply, with 120 volts, it's about to apply too much on the tubes, then running it at 60 is going to cut that in half and hopefully bring it into the safe range. So this first test though is just to prove that this thing will produce about 60 volts. Okay, I'm going to plug it in here. Yeah. Cord arrangement. Of course, this isn't going right into the wall. This is going from this transformer through another very similar transformer. Okay, what do we get? So we're going to get about 72 volts. That's good. That'll do it. Okay, we'll shut that off. I just want to clip them on there, and the radio's ready to go. Except I'm not monitoring the critical voltage. So to monitor the critical voltage, I got to find the right place to clip on a voltmeter back here. So we want to figure out probably at the output, probably right at the output of this rectifier somewhere. There's a resistor, I think, probably just on the other side of the resistor. Let's take a look at the schematic. So this being a communications receiver, it comes with a pretty thorough manual. There's an important document here. It's going to show the parts and their numbers. Here's the listing. Way down here is the stringing diagrams, and here we are. So the part we're interested in the schematic is down here where the tube string is laid out. So let's zoom in on that. Okay. So the end of the string is grounded, and you see they rate 0 volts there, because if you read the voltage here to the chassis, it would be 0, because you'd be reading the chassis to the chassis. And as you work your way up the line, each step of the way, you get a little more voltage. See the 1.4? You see that written there? Other side, oh, I'm starting to remember some of this stuff. Trouble in this heater string. I seem to remember now. As you work your way up the line, the voltage goes up and up. Here it's 3.1, here it's 4.8, and right at the top, 9, right on the 80. Oh, so that's easy. So I have to put a voltmeter on the 80 microfarad fat capacitor, and or pin 7 is even more certain, perhaps. Pin 7 of the 3V4, and I should look for 9 volts. Upon, so I turn on the set with 75 volts, this 9 will be 7 or 6. That would make me comfortable. Another issue along here is I'm probably going to change this rectifier and put a silicon rectifier in. That's going to raise the voltage in here a little bit. So I have a 2000 ohm 10 watt resistor. 10 watts, the whole set is 20 watts. No, this is what's controlling the, or dropping the bulk of the voltage before it heads out here. And then here, the high voltage spot right on the capacitor, this is probably the lead going up to, oh, there's another 40 here. Another 40 here. Okay, that's where they are. Triangle, square, half moon. If I can possibly see those symbols. Most of the time you can't utilize these symbols when the part is in the radio already. I've got to read these notes. Resistance in ohms, come on. Resistors a half line. Intermediate frequency 455. Tone switch showing right hand. Power change over switch S showing an AC DC position. Showing in AC or DC. So the idea here is you can feed this radio with 120 volts AC, and if you had it, you could feed it with 120 volts DC also. Who's got that? Nobody these days. Line voltage operation, 117 volts. I'm good. All voltage to measure VTBM between the socket terminals and what's that? 8. I don't know what they mean by that, but there's the chassis ground symbol there. Voltages are DC positive. Voltage measured in broadcast position with stick loop or loop antenna disconnected and gang fully closed. On some sets, C11 is 220. I'm making replacement use of 270. In some sets, oh, that's a little symbol. In some sets, this lead is connected to pin 7 instead of pin 7 of, oh, it's an error. It's an actual error, I think they're saying. In some sets it's connected to that instead of that. It doesn't say it's an error, it just says it's done differently. Well, who knows. Okay, back to what we're up to here. I'm all set to go. So look at this, how they've shown this. The chassis is shown with this symbol. This is the chassis symbol normally. And this symbol, which is normally a ground rod type symbol, is being used to mark where B minus is. So B minus runs separately in the radio from the chassis. That's something worth noting. It's a communications receiver, so not surprising. You use the chassis as your B minus because you're cheap. You want to spare the wire. Okay. I've been yapping and talking forever here, but I think I'm ready now. I mean, there is a risk here. That's why I'm going so slow on it. There is a risk. I probably built up enough anxiety over it now. Let's go back and we'll actually try it out. Oh, I have to find this point. Oh yeah, so I did find the point. Top of the 80. Or pin 7 of the 3V4. Let's use pin 7 of the 3V4. Unless it's really easy to get to the top of that capacitor. And the answer is better to go with the 3V4, I think. So where's the 3V4? If I were a 3V4, where would I be? I would be somewhere on a diagram in the manual that shows me where it is. So I'm quickly zooming back through the manual here, looking for where the tubes are located. 3V4. Just bear with me a moment here. Here we are. I'm going to find it here. Just hold the fort here. No, of course course it gives it V1, V2, and that kind of thing. Okay, I gotta find out what the number is. Here we are. This is better. I got it. 3V4. 3V4 for sure is this guy up in the back here. It's got a green piece of masking tape on it, which kind of means I probably replaced it. So 3V4 is here. Oh, it's also got this on there. 3V4 and pin 7. Pin 7. So I got 1, 2, 3, 4, 5. And so pin 7 happens to be where this resistor is. Is this the dropping resistor? This is a 15 ohm resistor. I'm sure I put it in there. I don't remember exactly why. 15 ohms. I don't want this. This clip is just going to be loose here. Right on the wire. Wow. That's good. That'll do it. Okay, so that'll bring back the 9 volts to examine. Take this up here. Put the power to the power. Let's move this out of the way here entirely. Go. Okay, let's clip these wires on here. Do it so it hides most of the copper. Stranded wire here, you gotta look careful to make sure there isn't a strand sticking out. You might miss, and you will find it later. You will not be happy about it. And because I just can't keep my eye on everything, I'm just going to cover those 2 connections. This is just lousy masking tape. It's just to put a physical barrier in here. Nothing more than that. And keep me away from it too. You know, I might lift a tool up and not be looking and bang into this. That looks really good. Oh yes, voltmeter. And what was that symbol? Now the symbol, I think they used the chassis for this part. The symbol at the end of that string, let me just take a peek at the schematic here. The symbol at the end of the string was, oh my gosh, come back here. Was a B minus connection. Okay, B minus. Where's B minus in here? We can start with the big capacitor and look for black wires coming from it. And sure enough, so I see the capacitor here. I see all the terminals. I see all the wires coming from it. They're all red. No, I was going to say they're all red, just one black. Black here and black up here. Now if I look carefully, I can see that those terminals with the black wires are not inside the body of the capacitor. They're attached to the shell. They're outside. So you got terminals here and then terminals, 2 terminals on the outside. It's the outside. So for sure that's the B minus. Believe me? I believe me. Okay, so I'm going to try to clip onto that without contacting the chassis. That's the trick with that one. This one up here is actually a little clearer. This comes off every time. Well, what if I try that other area? Looks like it's going to stay okay. It's very close to the chassis there, so I think it's okay. This is the ground. Okay, so all this is just finding out if I can plug this radio in safely. That's what this is all really about. Without burning out all the tubes. Switch on the radio itself. Where's the on-off switch? Right here. On. So we'll have it off to start. That verifies the on-off switch is working. How would I know that? There's no light on this radio. You cannot see the filaments in the tubes unless you really look hard. How would you even know the power would come on? How would you even know? This guy. This guy will tell me the power is on to here. There's no question it's here. If it's here, there's really no question it's here. Don't need to measure this. I know what it's going to be. 70 already. Still have the dim bulb in the circuit, just in case everything blows up. Okay. Switch off. Here we go. Okay, nothing should be happening in this radio. These things tend to come on instantly too. Because the tubes have no cathode sleeve, they're direct to the heater. Come on like that. Turn it on with the power supply, put the volume about halfway. Here we go. Keep my eye on this meter. If it says anything above 9, I bail out and think about it. Okay. Wow. Okay, lots to think about here. With half the power being supplied, I got 8 volts here. That really suggests that if you put full power onto this radio, you're going to get, 16 volts across those tubes, and one pops, they all go, kind of thing. That's what I'm worried about. Lots of sound came out of the speaker. Humming like a son of a gun. Could be for any one of a number of reasons. If I go ahead and start changing stuff, like for instance if I change this, I'm just going to increase that 8 something volts higher a little bit. It's kind of going in the wrong direction. I've got a big electrolytic here. I could maybe guess this is bad, and that was part of what we were hearing. I can change this guy. So a large wattage resistor here, and there's something funny going on right on the end of it. I'm going to assume the hum was from a power supply. We can continue operating the radio safely for now this way. Even though the B plus will be extremely low, it would be extremely low. do you end up with this voltage? 8 volts on the string. This could be the first time I've operated the set from power, from AC power. And it could be why I still have these guys in here, this guy and the big capacitor, because I've only discovered now that they're shot. Before I was using DC supplies, pre-filtered. It's an awful lot of work to change out or replace this great big guy here. That's a lot. It's pretty tight in here. Looks like I might have an interest in changing this resistor because of this. Looks like a melt out here. I'm not sure what that is. Be working in this area, kind of clean it up, get access to the terminals. A lot of wires in there, boy. That's a lot. It's the kind of thing you really want to insert the terminal. Wow. So I think I got to go away and think about this before I make the next move on it. Yeah, I got to think. I got to give a little bit of time to go by, so I don't make the wrong decision here. I got to give time for all the bad decisions to come up before I pick one. So after a little bit of consideration, I think the approach I want to take is to verify the resistive components that are in the power supply leading to the 9 volts that go to the tube heaters. And that involves this big 2000 ohm resistor. This is a 10 watt resistor here in a 20 watt radio. This is a 2 watt resistor up here. I thought this was a capacitor earlier. This is a resistor here, great big fat 2 watter. I want to check and see that these are the correct resistances. There's some smaller ones here and there that are all associated in this part of the circuit. So I'm going to verify those. Here, let's just take a peek at the schematic here. Now, so what I'm talking about, if you come in from the plug, you start encountering resistors. Here's that big 82 ohm 2 watter I pointed to. And then here's the 2000 ohm 10 watter here. Here's a 3.3K down this way, and there's another one up this way, although the rest of the radio is up this way. So I want to verify these resistors. I've put in a 15 ohm resistor for reasons I don't know yet. I think I put it in right in here. I'm not sure what I did there, but 15 ohms. Is there anything here that's 15 ohms? I don't think so. 100 ohms. 68. So if you notice, the heaters on all these tubes are bypassed with resistors. 82 ohms, 120 ohms, 220, 1.5K. I don't see anything here having anything to do with 15. So off the top of my head, I cannot recall why I did it. There's nothing here like it. And there isn't something to be mixed up, like 150 or 1500 that I would think is a 15. Okay, so, well, maybe this. Oh my gosh, it's right on that. It's from pin 7 around to pin 1. Pin 7 to pin 1, 1.5K. And I really have a 15 ohm resistor in there. Oh my gosh, is this a mistake? 7 to 1. Quick, let's go back and check it. Oh my gosh, pin 7 to 1. Pin... Is that what I did? Did I do something dumb? So this is definitely pin 7. And it's not going to pin 1. It's going to this resistor, which is on pin 5. So it's between 1 and 5 with a resistor coming off of 5. Between 7 and 5. 7 and 5. 7 and 5. 220. So 5 is the center tap. So the center tab often is used to power a light bulb. I don't know about these 3V4 tubes with almost no voltage on them. So I don't know what's going on here. What's going on? Why do I have a 15? Is a 220 still in there between 1 and 5? Oh, my gosh. Oh, I know the mistake I'm looking at. 220. Let's see if there's a 220 between 1 and 5. Gosh. 220 between 1. Well, there it is there. This is 8. 7 rather. Between 1 and 5. 7. What have I done? Well, without knowing what I was up to here, this is supposed to be a 1500, and I got a 15 in here. This is bad news. So I don't know what I was up to before. I was powering this with a separate supply, not from the inherent power supply. So I got to sort this out and check these other resistors for value and make a decision. I think I got to. I think I replaced the resistor that was in here because it had burned open. And why would I stick a 15 instead of a 1500? Just when I was working, one of the phrases we had in the company I worked in was, "Don't look for another answer when stupidity will explain it." And I came up a lot, I have to tell you. So maybe I was just stupid about what I did there. Okay, I'm going to think some more, check those resistors, and go forward from there. So the resistors have checked out, except for this one. This nice looking one here, it should be 220 ohms. And when I check it, on the 200 scale on my meter, for a 220 ohm resistor, I get, you see that? It's hard to see. About 8 ohms in circuit. 8 ohms. There's lots of other stuff hooked up here. In fact, there's another circuit through this 15 and then through this resistor back here. What is that? That is a that's a fair size one. Brown green. Looks like maybe brown green red. 15. That's a 1500. That's the 1500. I don't know what's going on. Stop. So the situation is causing me to study this string more and more, and I'm seeing more and more. So what I've noticed is 80 microfarads, 150 volt here. Look, there's another 80, 25 volt here. There's 100 here. This is in the back of the radio. This 80, that's part of the multi-section big fat capacitor. So is this 40, and there's another 40 somewhere. So, you know, you don't commonly find these gray big capacitors on the heater string in radios. This one is very different. It's a artifact of the fact that these tubes do not have cathodes. If they had cathodes, they'd need stronger heaters, more power, and a battery operated radio wouldn't last as long. So that's why. So this is the price that's paid for running these little tubes in this radio. Now I have a 15 ohm resistor I installed between pin 7 and pin 5. Everything else is there and everything else appears to be okay. Why would I install a resistor between pin 7 and pin 5? And you might say, well, you're the one who did it. Why did you do it? I don't remember. The only thing I can come up with is this leg of the heater is open in this tube. And I faked this heater leg with that resistor just to get the whole set operating. So I'm going to pull the 3V4 out. We're going to check the resistance between 7 and 5 and see what happens. Usually I'm guessing what other people did in the past in these arrangements. this time I'm guessing at my own work. Pull it out now. Why, it's got tape on it. Sort of. Well, sometimes I put tape on them as a warning. Sometimes I write on the tape, I didn't write a thing on it. So it's definitely a 3V4. Putting tape on is not the smartest thing, man. 3V4. Yeah, the tape is on the clean part of the glass. And it was between which pins? It was between pin 7 and pin 5. Okay. Let's find out. Pin 7. Pin 7 and pin 5, eh? Pin 5. Pin 7. Pin 1. Oh, meter, come on. So that's one half the heater. Isn't that right? Wasn't that right? Let me just double check. Be absolutely sure I'm doing this right. Yeah, 1, 5, and 7 are the heater pins. So if we go 1 to 5, we see no resistance. If we go 1 to 7 to 1, we should see nothing good. Not good, but then if we go 5, we get it. 8. So that's what I've done. I'm continuing to use this unhealthy 3V4 by using that. Hey, how clever was I? Man! Must be a clever guy who's doing this before. Come up with that idea. So we're going to carry on with the half-heated 3V4. I don't know that there's any kind of a problem with doing that, but the set is humming like a son of a gun. So maybe that's because of this crazy arrangement here. This heater string is so critical. So that, what's that tell us now? Resistor's all good, resistor's all there. Half a tube operating on the output, half a tube heater. Which I believe will make no difference except to run the tube colder than it should. I mean, it shouldn't account for a hum. So the likelihood of the hum coming from these capacitors and the filters is pretty high. Fiddling around with this big one is a monster. Why don't I put some instruments on here and measure the hum? I don't know. Why don't I do that? I think I will do that. And we'll measure the hum level. Right in the power supply. You can look at it with the scope, consider it as a percentage sort of thing. Percentage of the voltage that's there. So we look for a hum on the first 80 microfarad capacitor, or just on all of them. Which is which? So all the terminals are up in here. How am I supposed to know which is which? They have little symbols, but the symbols are, once you install the capacitors, the symbols down below are invisible. They're blocked from view. So one way is by telling where the capacitor is connected. That's the only way, really, where the connections are. So we look at the big 2000. One end of it is right onto this terminal. And along with it is a brown, black, red 1000 ohm resistor. So 2000 and 1000 ohm resistor on that terminal. What terminal is that? So I'm just looking over here for the 1000 and 2000 sharing the terminal on the capacitor. So the 1000, just bear with me 1 second here. 1000, the 2000, that's why I'm having trouble. The 2000 and a 1K. That's on the first 80. So that's the 150 volt 80. So that's the main filter guy. So if we want to look at the situation there, we want this on a B minus. B minus can be picked up here like quite nicely. And then we would put this, take this out of here, take this out of here. That was for measuring the string voltage. We would want this hooked up right here, like that. We put it on right away. It's on the times 10. Let's get the scope thing going here. We're on channel 2. We're hooked up. Super sensitive. Let's put it on, start with 1 volt DC. We expect 150 here. We'll better go up more like, well, if we do 5 volts is the best I can do right now. 5 volts, well, that's not going to make it. So we put this on a times 10. This becomes 50. Yeah. So this should jump 3 up or down. And then we should be able to see the ripple relative to the size of the DC there. Don't want to make the mistake of just focusing in on the ripple using AC mode, and of course you're going to see a ripple, but you won't know if it's significant. I think we're all set. I don't want to operate the radio for a length of time. This will be the second time we've switched it on. You'll be able to check the volume hum effect quickly, and anything else we can do quickly. We're just looking over here to verify the amount of hum. Okay, I think I'm ready. Don't need the voltmeter to monitor anything. Trust that it's going to operate the same way it did. Here we go. Okay, look at that. Didn't hear a thing. Didn't hear a thing. Set was certainly on. I'll turn the volume up a little bit more. Let's do it again. Here we are. So this rose about 2 divisions, and then the hum is almost a full division. So on that 80 capacitor, 80 microfarad capacitor, there is a whopper of a hum. That's just about enough to conclude it is shot. What more would I need to know? The only other way you get a whopping hum on there is because there's a huge current draw from it. I don't think that's the case. I don't think that's the case. I think we're looking at dead capacitors here. Dead capacitors. So before going in there and trying to rearrange all the filter capacitors in the set, I'm going to stop and think. This will be the end of the video for today for sure. I want to think before I commit myself to such a large amount of work, in case in fact it's really not necessary. Okay, well thanks a lot for watching, and we'll keep moving forward on this radio. Very excited about getting this radio to work properly. See ya.